I'm hearing like actually people coming out of the woodwork and saying that they kind of like Stadia now. So like maybe
Interesting.
that's just the
I haven't heard that yet, but
Me neither.
the thing I always thought was the nefarious Stadia plan. Now instead of being like, "Hey, Samsung, can you guys really just like use vanilla Android?" They're like, "Oh, it's just a stream, and it's great."
I
And,
assume this is the
and now
only-
you know everything that anyone taps on because you're getting all the input events. And
yeah. I won't even turn on Siri because I'm just worried about like my like voice commands going on the internet. And so contrary to like what we were just talking about, I'm kind of waiting for the for devices to be powerful enough to run the ML model for voice recognition because I just don't want anything going over the wire. I just want it to know. It should be smart enough to know.
That's fair.
yeah.
Yeah.
All right, so that was a little bit of a rabbit hole. Where were we?
Yeah, so we made it a minute before the hour tonight. That is, I think that's a record for us.
It's snappy. Yeah.
Last time I think we were 20 minutes after the hour because I was just like artistic, like I was just like artisanal OBS boundaries around the various views. It was a painstaking effort.
I spent 20 minutes on that tonight. I just did it early.
Planning in advance. Yeah, it's just like laying gold leaf into porcelain. It's a very careful procedure every single time. Yeah.
I feel like some introductions are in order for the stream.
Yes. Momentous occasion for Jeff and Dom make a game. We have our first guest on the stream. We've got Stephen Foote. Really thrilled to have him on the stream. Stephen and I, first of all, when Steve and I worked together, I called him Foot, like because that's his last name. It's also kind of catchy. But that particular workplace was very I don't know. I feel like a workplace where it's just a bunch of dudes who address each other by their last name. It feels very like 1960s Mad Men. You know, we've all got like the same ties and it's just like, hey, DeGrotty, hey, Foot.
I feel like it was like 90% last names, even though there wasn't that much first name overlap.
And the only reason why I was called Jeff was because there was another person called Lee, and that was their first name. And so in a concession to clarity, I was called Jeff. So I felt like I was largely spared of that. I don't know. Maybe people called me Lee behind my back or something like that.
I don't think that ever happened.
Do you have a middle name?
Do I have a middle name?
Yeah. For all the identity thieves out there.
It's Wan Cheng. Wancheng. It is my Chinese name. Yeah. Which when you're like Asian growing up in America, you desperately want the W to mean William or Walter or something like that, right? You spend about like the first 15 years of your life wanting to be white, and after that kind of burns away. And now I would say I feel quite the opposite to that sentiment.
You've arrived.
Yeah, I've arrived. Yes, very much. So here's the amazing thing is that like now, so I'm getting used to calling Steven, but I'm looking at his Zoom name right now, and it says Steve, which is astonishing to me because I don't think I've ever called you Steve once in my entire life.
Yeah, I was like, I don't even remember setting this. I'm sure I got it from somewhere, but yeah, at work I mostly go by Steve. Like family mostly calls me Steven, and Way Forward mostly called me Foot. So it's like, whatever. I got used to all of them, really.
Right. Okay. So for the purposes of this stream, this is a moment of like personal reinvention for you because you have the opportunity to basically set the standard of what we should call you. So what it will be.
Steve or Steven, I think is perfectly fine.
I'll go with Steve. I like I like monosyllabic names.
All right,
Steve
let's do it.
I sometimes say Dominic, but Dominic is fun to say. Certainly the most fun to say out of Jeffrey, Steven, and Dominic. I would take Dominic.
Syllables are fun, but I go by Dom too.
Yes.
It's in our domain. I can't undo that now.
Yeah. So carrying on with the introduction. Steven works at Scopely on mobile games. Are there any games that you're working on previously that have been released to market that you can talk about?
I mean, the one I been on for a while is in soft launch right now, called Avatar
nice.
Pandora Rising. Sort of still kind of getting that figured out. I wouldn't claim to have really worked on, but I did touch from time to time is Marvel Strike Force, which is doing quite well right now. But that was mostly jumping on for performance things and stuff to get it ready for ship. I wouldn't say that I really worked on it. So those are kind of the two main games of our studio.
And those are all those are both Unity titles. Is that right?
Correct.
Yeah. So you're kind of like a Unity guru at this point. But when I worked with Steve, boy, that feels weird. It's just strange. When I worked with Steve, so first of all, when I first met you, like the anecdote that I have is that like you were telling me about the game that you had worked on with your friends that also got hired with you at the company that we were both working at, and it was also a mobile game by coincidence, I think, right? And you had written it in Java, but then also wrote like a transpiler into C so it could be cross-platform. I'm not getting this wrong, right?
That's correct.
And that was like the most impressive thing to me. I was like, "Oh shit, that's incredible."
Yeah, I mean, it was because back then you basically like half the phones would use J2ME, so Java, right?
Yes.
And the other half would be on Brew, which is C++ for like all the Nokia stuff. Is that right? Yeah, I think so. For the Symbian Series 60 phones. So we basically created like our, the engines were very thin for mobile at that time because the games were so the phones were so crappy, right? So our engine was written in both, but for the gameplay layer, we're like, well, let's do something crazy, and it ended up being basically Java, where we only used a subset that mapped really well to C++, and then had a little bit of annotation, so we could go in and say, if my comment looks like this, uncomment it. So you could basically do, put a little bit of code for deletes in there, things like that. And then we had a file that would map pointer types to the C++ side. So we could say, this one's just an object, like use the dot, and this one's going to, use arrow. And yeah, so we just basically like converted the Java over to C++ with a light annotation, and it worked pretty freaking well. The way better than writing the code twice. The only downside is eventually we ended up, ripping a bunch of the Java like object-oriented stuff away to the point that the transpiler was probably overly complicated to what it needed to be, just because our smallest shipping size, I want to say it was like 64K maybe. Wow. So all the Java like class overhead and stuff like bloated the executable beyond shippable. So you just like rip out all the OOP and go to a bunch of enums and switch statements.
So it's just like one giant Java class with a bunch of arrays in it.
Yeah, eventually our gameplay ended up being that effectively, right?
Right. And so what was the actual game?
It was a Nightmare Before Christmas.
Nice.
It was those Sokoban like box puzzler.
Oh, totally. Yeah.
Push things around.
Yeah.
And we did that for Disney at the time, back when mobile contracts were really, really, really terrible, right? Which is why we ended up joining another company after shipping that title and realizing we got like $0 of profit.
Right. The game did launch then, it sounds like.
Yeah.
Nice. Yeah.
Verizon store, right? Before the App Store sort of thing.
Right.
I say that's so funny. My very first job in tech was working on Adobe Flash for Sybians, and it did not work.
Yeah, I can't imagine that even running.
Not even slightly, but they tried really, really hard because that was like the only phone that existed at the time that could even install software.
Yeah, we for our senior project at school, one of the teachers was like, "Oh, hey, this Engage thing is coming out. You guys should do this, right?" So that's actually our first experience with the like Nokia phones, and we're like, "Oh, we'll take this like PC engine that we wrote and we'll port it over to Engage, and hey, we'll do like 3D because it supposedly does 3D, and we'll use OpenGL and all this stuff." And we eventually got it running on the device, but it took like, I think like a minute or two to load in, and then ran at, maybe 1 FPS, right? We're like, oh crap, are we doing something wrong? And eventually dig up all their samples and put like just their cube on the screen, and it's like rotating like 2 FPS. We're like, okay, like I think it ended up being like most people were doing like software rasterizers just because the OpenGL implementation was so garbage. So it's like, we can't do this. And then we ended up like learning a little bit more and shipping like a 2D box pushing game with Disney based on kind of like having done a little bit, even though that project pretty much failed.
Right. Well, that's cool. I mean, to work on like, I think almost forgotten technology, right? Like it's sort of like access into a world that's just like no longer here. That's really cool.
Oh yeah. It's like talking to people now where you're like, oh yeah, we had to fit a game in like some number of K, and we're like looking through Java bytecode to get memory back and storage back. It's just not something people deal with now. Is evidenced by like working with Unity. It's just like kind of lazy with memory and storage and all these things, and it's just like kind of shrug whatever you deal with it. Like you do some light profiling afterwards and trim a couple of things down and hope for the best. It's like so different.
Yeah. Dom and I were just talking earlier today about like we've both been excited about like the M1 Max that were just recently released, and how it's just giving so much like CPU headroom. But then we were kind of joking about how like essentially it'll just basically take 6 months for whatever like Electron or whatever program to basically absorb that headroom, and we'll just be back to the same slow morass that we're in right now.
We will see. I'm optimistic. I feel like my computer now is still better than my computer 10 years ago, even if it's a slow morass.
Yeah. So yeah, Steve is on the stream because he's, unlike us, is a like veteran game developer, and boy do we have problems. We've got tons of different problems we could talk about, but we thought a fun thing to talk about today would be our multiplayer implementation. To speak of things like game engines that aren't very memory that aren't very careful with their memory. We're writing this game right now in JavaScript, right? It runs in the browser, so we're firmly in that zone. And yet we have enough going on where we actually feel a bit of the performance problems that all seems to imply. And we don't think I don't necessarily think it's a matter of like micro optimization. I think it might be an architectural thing. So it might be fun for us to like kind of talk about how the game is put together from a multiplayer perspective, and then maybe get an insight from someone who knows a lot more about the stuff than us. Not necessarily what we should be doing, but like what's out there and what the options are. That kind of
thing. Sounds good.
Nice.
I'm gonna kick the stream over to desktop view.
Yeah, let's do it. Do you guys want to play the game? Should we just play the game?
Let's play the game.
I think that'd be good.
Okay, let's try playing the game. So we've never actually tried this with 3 people. So it could be a smashing success. It could be a complete disaster. So we'll see. We're used to disasters though, so that's not the worst thing in the world. Okay, so I have a URL that y'all can join. It is either HTTP or HTTPS, depending on which flavor you enjoy. And then it's Jeff and Dom. That's JEFFANDDOM .ngrok NGROK.io, and that is essentially just a internet-facing tunnel into my computer that's streaming right now. And I will actually attempt to go to the same thing and see if I can join.
I'm already in. I might have joined an old instance.
Oh, you know what? I didn't bump up the player count, so it's just Dom right now. So I need to
okay. Yeah, I was like, player -1. With a
I'm
bunch
also
of
player
fuchsia.
-1. It's okay. Solidarity on the -1. So let me actually bump up the player count, and then one thing this works now. One thing I'd noticed before is that it didn't seem like the file system events were triggering a rebuild, but it's rebuilding now. So y'all should be able to reload now.
Oh, I'm in.
I was actually unable to open a WebSocket for me.
Huh.
Oh, failed to complete tunnel connection.
I'm gonna blow up your tanks.
Let's try it without the S. Dom, did you use HTTP or HTTPS?
I'm on HTTPS. You want?
Oh, so am I. What do we think the issue is here? This will work with 2 people, right?
Take it down to 2 and see if you can.
Let's take it down to
Steve
2
can get in
and
there.
we'll try again. So we're gonna debug live here. It's down to 2, and then I'm gonna reload right now. Yeah, for some reason locally I'm not able to load. Are you both in right now?
Not.
You're not. Dom, are you in?
Oh, I was trying not to open it so that you and Steve could get in, but let me hit the end grok. Now I get a failed to complete tunnel connection.
Okay.
What'd you change?
What did I change? Well, I added. Of course, there's this long story. What I actually changed now. The WebSocket client connects to either. I made it so we could work with HTTPS. I can roll that back.
Yeah,
Just make it.
Maybe so.
Yeah. So that's just this.
Yeah, let's do that.
Um,
So we have to use HTTP now. That's
HTTP.
okay.
Yeah. We are also hot reloading now, which maybe is a bad thing. I don't know.
Ooh.
All right.
Player 2.
Hey, there's Steven. So the WASD to move around, the mouse will.
Okay.
Let me try. So I'm going to try reloading again with 3 people just so I can get in because it's my screen that's being shared right now.
Fair enough.
And I want to play. It's mine.
Okay.
All right, 3 players.
Neat.
So you do WASD to drive your tank around. The turret will follow your mouse pointer. You get to shoot. Steve, did you ever play Bolo on the Mac?
Oh man, that sounds vaguely familiar.
It kind of looked like this. You got a tank that you drive around, and yet we're also trying to basically have a little bit of a real-time strategy component to this, where when you destroy things, you can pick up resources and build things. So the idea is you can sort of drive around and either be good at shooting things, which neither of us particularly are, or be good at building things and being strategic about them. You can drive into the trees. I don't know if you'll notice, if you focus on one of us, if we drive into the trees, we disappear. The turrets respect that as well, so you can kind of go invisible. There are some walls we can blow up. We can run into the walls, so there's a little bit of collision detection going on there. If I blow these walls away, the turret will start shooting at me because now it can see me. And that's pretty much what we got going on for the game right now. We actually had a lot more going on when it wasn't a multiplayer game, but then we've kind of been working on multiplayer for the last, I don't know, 2.5 months at this point.
Yeah.
Feels like it's been a while. Can't remember when we didn't have multiplayer, basically.
Yeah, I feel like I'm in some weird mode where all my inputs are being rejected rather quickly.
Oh no.
Oh, interesting.
It was working, but yeah, now it's like, hey, everything, snaps back to
Yes.
what it was.
Pride.
So there is a number. Oh, by the way, which browser are you using? Just out of curiosity.
Chrome.
Chrome. Okay. And there's a number in all that debug output that's in the upper right-hand corner. There's one that says FAOS. That stands for frames ahead of server. What is that number for you? Is it negative?
Negative 850 or so.
Okay.
Oh no.
Cool.
Okay.
So I think that's actually maybe understandable. Basically, I think that's actually a nice subject to talk about today is basically like how long will the server wait for you to send your input before it just moves the world ahead? And if you're too far behind on if one of the clients is too far behind, it's basically just never able to catch up to the server. So the server is essentially going to like override whatever is happening locally.
Right.
Cool. All right, so that's kind of the game. Hopefully, despite the fact that your input was locked, you were still able to kind of see what's going on.
Well, I was driving around for a little bit,
yes.
So I'm assuming there was some basically drift, right?
Yeah. But you can see me driving around right now, right?
Yeah.
You can at least see
that.
Yeah. Okay. Cool.
Which browser are you guys using?
We're both using Chrome. We found that Chrome is actually the most performant of the browsers we've tried. I typically use Firefox, and Dom is a Safari guy. Go figure.
I'm actually in Firefox right now because that's what I have on Windows.
Oh, there you go.
But I am aware who likes Safari. Yeah.
Yeah. But we're also both running on relatively high-powered gaming PCs right now with lots of cores. But at the same time, I don't necessarily think the fact that you got into the state that you did is necessarily due to a performance thing. It's an architecture thing, right? Like we don't know how to.
Yeah. Unlikely. I'm on like a Razer Blade, so.
Yeah.
Oh yeah.
Yeah.
I was gonna say I was about to pull up my Mac and be the slow computer.
Interesting.
And I will.
I clicked away and now I'm like frames ahead, positive.
I think
spiraling out of control the other direction.
Oh yeah, so. I think the server crashed, right? So basically,
now
any
I'm just
communication
in control
with the server,
of my own fate.
Exactly. Yeah, but you're not going to see either of us moving around anymore. So I'm moving around on my side here, but you're probably not seeing me move at all, right? Presumably.
Yeah.
Oh, you know what it is? I think I died.
You died, yeah. So we basically had like essentially a dangling pointer error. It's not we don't have pointers in JavaScript, but it was more or less the same thing. Use after free, right?
From what I can tell, yeah, you have these like turrets that shoot at you. You have trees that can be killed, like blockers and stuff.
Yep.
All networked and rendered in some JavaScript madness that I probably don't understand as not a web developer.
And so all of this is like our whole multiplayer setup. We kind of got the idea from it by kind of cobbling together like stuff that we've read on the internet. But in particular, there's a video from GDC, I want to say 2 years ago, that was about Overwatch's multiplayer implementation.
Yeah, I've watched that one.
You have. And they also talk about ECS as well. You know the one that I'm talking about, right?
Yep.
And so we more or less tried to kind of copy what they were talking about. Not necessarily because it was like we had decided that was the best way to do it. It was more like that was the clearest explanation that we could find.
Okay.
And so, like, have you ever seen like a ancient Chinese drawing of an elephant or a lion, like an African lion?
No.
It's like there's these classical, like you go to these museums and there's like these old paintings of like animals that did not exist where the painting was created, and they look nothing like it's like a Chinese drawing of a rhinoceros or something like that. And essentially what it was like basically people describing what a rhinoceros looked like to some dude, and that dude going to China and then like relaying the message about what a rhinoceros looks like, and then a painter in China going, okay, I have this like fourth hand knowledge of what a rhinoceros looks like, but I have to paint one or else I'm going to be executed by the emperor. So like that's basically what I feel like our multiplayer implementation is, with respect to like probably how other games might do it. It's just sort of like an interpretation of an interpretation.
Right.
Which is not to say that it's bad. It's just like it's gonna look pretty unique, I think, when we explain it. But so, okay, now that we played the game a little bit, would it be a good idea to just like start talking about our architecture a little bit? Would that help?
Yeah, I think that'll get us all on the same page.
Okay, that sounds good. I'm gonna go ahead and close this tab just so I'm not burning CPU here. And is it all right if I switch to whiteboard view? Does that work?
Bring it up.
Yep.
Cool. This is Microsoft Whiteboard. I actually quite like this program. It's pretty cool. I've never used it before until last night because I was like, oh no, I'm going to be running Windows. I'm going to try this. But I am able to use my iPad to operate it, which is pretty cool. Dom, where do we begin?
Let's see. We've got multiple clients and we are sending every input. I feel like the way we're handling input and messages to the server maybe is a good place to start. And then then you reconcile from there.
Yes. Okay, so we've got, let's say, a server, right? And God, I'm drawing on the fly. Let's make time go this way. And when I say time, I mean wall clock time. I don't mean like frame time. We'll use some other indicator to like indicate like frames, because like my frame 5 might come a few seconds after your frame 5, right? And right. So when the time going from left to right on the whiteboard is actually like real time, like wall clock time that we're all experiencing. Let me just make a couple of clients so I can do some crazy stuff if we need to. So what will happen is client A will simulate, let's just say, frame N. This is just like the frame that we're simulating right now. And the frame will basically, at the beginning, will collect input from the input devices, run physics or collision detection or all those things. In parallel, we do a render. So like the render is not in line with this. We just use whatever async services that JavaScript in the browser gives us. And at the end of this, it will send to the server, how do I say inputs of frame 1? Let's say input of client A of frame N. Good God. I'm already in notational hell, and it's like I've barely started explaining this stuff, right? And then let's say with some time delta, client B is also simulating frame N, but it's maybe like obviously not exactly the same time as client A, right? There's nothing that's synchronizing the two. It's just whatever's happening on their computer. We essentially have a timer callback that's running in the browser that says, okay, when you hit like 1/60th of a second, call this function. That's essentially what our update cycle looks like on the client side. It's also about how the server works as well. And at the end of that frame, with some amount of latency, it's going to send input of client B for frame N, right? And then what the server will do is the server has basically a kind of grace period. It's like a buffering time that it will collect client inputs for a particular frame before the server actually attempts to simulate that frame itself. Mm-hmm. Sorry, I felt like I could have communicated it more clearly. Does that sort of make sense?
Yeah, that makes sense.
Okay. So what will happen at this point is that like there could be a client, for example. Let's say client C, and this is actually, I think, what happened to you. That for whatever reason, their frame N is just being simulated pretty late, or their network latency with the server is like really, really big, right? And that may mean that the slope of this line that it takes to actually transmit the data could be like really slow, right? And in any case, this point right here is way outside of our blue buffering period. So as far as the server is concerned, that input just didn't happen, right? The reason why you might have seen it happen a little bit is because we do some prediction on the client side where it's like, we're going to actually animate your input even before the server recognizes it.
Right. So you're letting the client play that out.
Yeah, exactly.
And I think I'd get, whatever, like half a tank, and then it would pop back.
Yes. And what was causing the popbacks is what I haven't explained yet, which is how does the server actually tell everybody else what happened, right?
Yeah, and this is probably what you're getting to, but I assume because my snapback was happening so quickly that it's actually not a time to server, like it's not a ping issue.
Yeah.
Because otherwise, I imagine I'd go on my merry way, like old school, like Counter-Strike, where you're like running through the corridors and all of a sudden you're 10 rooms back. That's definitely not what I was experiencing. Mm-hmm. So yeah. What do you do with those rejected inputs?
So they basically just disappear. So what happens is now the server will broadcast to everybody at the end of its frame the accumulated inputs that it received. And so it'll basically send to each client. I don't know if I'm lining this up correctly. What this is the set of the inputs that it received. And that set does not include the input from client C for that frame because it was too late, right? That's just the example that I've kind of cooked up right now. So the question is, what do the clients do with this? Because they're at this point right now, let's say that client A has been kind of simulating its merry way. And let me use a different color for these. And has basically like done a bunch of these frames. Let's assume that client A is very healthy, right? And can do this, has like a fast CPU and the browser is not misbehaving. And so it can basically stick to 60 FPS for the update logic. Everything that's in green is what we call, I guess it's just like pure prediction. It's all client side. It's all basically stuff that the client has predicted based on whatever inputs that have been received after frame N locally on client A. But then let's say at some frame over here, which we'll call frame X, let's say. Frame X, something interesting has to happen, right? Which is the client basically has to say, oh, by the way, back on frame N, it turns out that client B also had this input, right? So what we actually do, and this is the lesson that we kind of gathered from. I'm gonna just clean this up really quick. This is input B, frame N. What we're interested in right now is what goes on right here, right? There's we have to do something to kind of reconcile with the fact that on frame N, actually we had this input from client B. So what we do is we actually roll back the entire simulation state on client A to a last known authoritative state. Let's just say that was here, right? And then we basically play back this frame N, assuming that both the input from client A and client B happened, right? And then that'll give us essentially a new, that'll basically give us a new version of this here. Actually, it's probably better if I use a different color. I'm running out of colors, guys. I'll use red because red means like authoritative, let's say. This gives us like a new kind of authoritative version of frame N, and this becomes our new high watermark of like the last known authoritative state that we received from the server. And then we will also have buffered all of the input that we had collected in this amount of time on client A, and we'll just like basically play it back on client A. We'll essentially just like replay that buffer of inputs. So let me stop right there and see if you have any questions. Dom, is this sounding about right to you right now?
It's sounding right. Yeah.
Okay, cool.
Reminds me how complicated this is.
Yeah. What's funny is I actually think this is actually not complicated in the absolute sense, like in the abstract sense. It's complicated in terms of like getting it to perform.
Yeah.
So you said earlier that your time is not synchronized in any way.
Our times are. We don't do any synchronization between clients, so they're all just kind of like moving ahead at like 60 frames per second, or what they believe, what best effort 60 frames per second, which is to me is what accounts for the drift between what was going on in your computer and what was going on in our computer.
The only synchronization we do is that every client is waiting with the WebSocket open until every player has joined. The server dispatches a start game message to everyone at the same time. So there's like
Okay.
they're all starting together modulo some network lag.
Yeah.
Okay. So there's no late join.
Not right now, no.
And everyone starts at the same time, kind of.
Yeah.
Yeah. I would say the one piece of synchronization that we do is that the server will not try to simulate past the most recent client frame. Notice how the server's frame n is always to the right in this diagram of the client's frame n, or at least the clients that are able to get the input in. That means that the server is basically behind by a certain amount of time, like always. And we do have some logic on the server side that says, I'm not going to attempt to simulate past the last frame that I got, like the most recent frame that I got from any client, right?
Right. Does it send the confirmation input out before it gets it from everyone?
When you say confirmation input, do you mean the stuff that was over here, like this stuff here?
The red lines back to the other clients.
Is there a way I can point in this whiteboard?
Without trying.
I guess I can do this.
Yes, all that stuff going back to the clients.
Yes.
That all happens in one fell swoop.
Yes.
Yes.
And in this case, like client C its input will just never end up in that bucket.
Yeah.
So we don't wait for every client to send us frame n. Yeah.
Right.
Yeah. So we have a very chatty protocol. For every client, at the end of every single one of their frames, they send a packet of data to the server that says, this is the input that I collected from this frame. We don't like buffer it on the client side for like n number of frames before sending out to the server. Again, we haven't run into any issues that we think are attributable to network issues, because we're like, Dom and I live like a couple miles away from each other, and we're both on Sonic Fiber. So it hasn't been like network optimization itself hasn't been the thing that we've been worried about.
Yeah, I mean, the only thing I'm really worried about there is just the reliability of WebSockets potentially being a problem.
Yeah.
But if you
totally
tend to not be falling behind because you're just resending a bunch of stuff behind the scenes.
Yes. No, that's absolutely possible. It's also this protocol is also super chatty in that the server is also when the server finishes simulating a frame. If you think about it, it's also sending a packet of data to every client, right? We only see one of those examples in this diagram, but I mean, this diagram really only shows one frame of action, right? And so this whole process is being repeated every single frame from every perspective, from the server perspective and from all the clients.
Right. So because you don't have any notion of joining the game late, is there no way to clean, like if someone has a really long network hiccup, is there no way for them to basically get back on track? Is that potentially what I saw? Like, hey, maybe a hiccup for 300 milliseconds, but your input window is 250, and I will just plod along repeating, or basically I'll never catch up in any way, or will you burst through and catch me up to that last server frame that was sent out to get me back on the time?
Right.
Yeah, did you see the word overdrive pop up on your screen? Because maybe you missed it because it's.
I may have.
Yeah, So we do, when a client falls behind, we tell it to start running a simulation twice as fast every frame, with the hopes that, yeah, if it had a hiccup, it should catch up to the other clients fast enough, though. Yours clearly didn't, so.
Yeah.
Right. In that case, you omit rendering, right?
No, the game starts running a little fast. Right?
Yeah.
It'll render fast, too, for that client.
Right.
The
Well,
render will basically just render whatever's available, but it's still running.
there's no like blocking on vsync or something like that that's actually capping you more than you think you're being capped.
There is basically we use with JavaScript, everything is single threaded in the runtime code, and essentially there's just like a loop that you don't actually see that runs callbacks. And we essentially have two callbacks on the client side. One callback is the update logic, and we basically set that to a timer, right? We say like every 16 milliseconds, call this function. The second callback that we have is like on the vsync, call the render function. So even if a client like knows that it's behind, we currently don't have a mechanism to say like, I want you to do less rendering or anything like that. Cause we're just like, there's a callback that's just getting called like every single time there's a vsync anyways.
Yeah, I wonder if that actually attributes to the issue. Because does that mean you're actually getting your running at 2x? Like, if you're incapable of running 120 FPS with how the callbacks are set up, can I actually ever catch up?
You can't. Yeah, sorry. Go ahead.
I was gonna say the way we simulate that is that in the in our like game tick callback, we actually it's a loop.
Okay, so you'll just loop that a couple times.
Yeah, just like it'll just tick twice.
Then the
for every
vsync
tick.
callback hits. You do one render. So in theory, you could render or calculate double the frames in a single render. Okay.
Yep.
Yeah. Yes, Steve, you're. It's a good observation to point out that like we don't really have a great way of catching up a slow client. I mean, I think for what Dom is talking about is kind of like a partial way of doing it, but what we don't have is a way to say, here is the entire state of the world at frame X. Take it. Like we don't have a way of delivering like the entire state of the world. So there's like no way currently to kind of like join the game after it's been played for 10 minutes. Right.
Right. Regardless of if you, I don't know, get a hiccup.
Exactly.
Like I guess that's also the other question of like how much input does the server send back? Because if you have a hiccup longer than that server input window, then you'll never ever get back to a valid state.
Yeah.
Well, that's a good point. That breaks down our determinism a little bit.
Yeah. I think what I'm writing down here just stuff that we're observing about like the way the system works right now, which is like where there's no catch up or like full state transfer, whether the full state transfer is for joining the game in the middle of it or for recovering from like a major amount of like a large amount of latency. Right.
And I mean, to be fair, there have been games that have been that way, but most of the time you can, right? Like even like bigger state like RTSs and stuff like that tended to have some way to jump back in, right?
Yes.
Probably, I assume, by doing a full state transfer of some kind before you get back in the lockstep.
Right.
But there have been games that are just like, nope, player disconnected, it's over.
It's actually fair to say that we actually don't do a state transfer at all. Right? And let me elaborate on that a little bit. What we rely on actually is like essentially like a fully deterministic like update. And this is actually an idea that we borrowed from that Overwatch video, that Overwatch presentation, where they basically said that like any meaningful simulation on like is fully deterministic, which means that like given the same initial state and the same set of inputs, any one of these peers, the server or the client, can basically resimulate the true state of the world based on that, right? And so there are certain things that we do to like basically enforce that. We have like a fixed time step um, for updates that is actually not attached to the amount of wall clock time that has passed since the last tick. We'll basically our in order to make sure that we don't have like floating point drift when we do our math and that kind of thing, we're always sending in like 1/60th of a second into the as a delta time into our update, right? And then we always I don't think we have any randomness at all in the game, right, Dom?
Not right now, no. And yeah, I'm not sure how we would handle that.
Random is it's not too big because we could just send the random seed every frame, or just like synchronize the random seed at the beginning of the game. And if everything else is deterministic, presumably every function would get called in the exact same order, and like every call to random would get what we
yeah.
want. Yeah.
That's actually an interesting thing that I don't have enough experience with like browsers and things like that.
Yeah.
I would hope there'd be some uniformity there, but if they have different pseudo-random functionality, that's not guaranteed, right?
Right. I mean, worst case, you could use your own pseudo-random library, right? If there was no
you could pull
equivalent
yours
to, like,
in.
Yeah, you could even just use like a hash function, like a cryptographic hash function, and just hash the last value that you got out of it, right?
Yeah, and I mean we've in some of our like C++, I think rand stuff where we try to get some determinism across networks, I believe we tend to pull in our own library just to avoid any of that weird stuff. So I mean, the code is not even a page long, right? It's like so that would definitely be a thing you could do there. But if you're using just whatever JavaScript rand.seed or something, I have no idea. Maybe it would work.
I
Maybe
actually have no
standard.
idea what it is. What do you?
I have no idea.
Dom, have you ever had to use randomness in JavaScript at all?
I always include like crypto.js to get a proper random library that's not pseudo-random. So
okay, so it's probably just secure random, and it's just getting like it's like a hardware source of randomness or something like that.
Yeah. I've never relied on browser randomness, especially not across two pieces of hardware.
Yeah, I guess
randomness that would be a pretty easy thing to go test, right?
Yeah.
So like load it up in Firefox and Safari and then Chrome, and with the seed, are you getting the same thing? And then load it up on your ARM device, pump through that a couple times, and if you get the same numbers, you're probably good.
Yeah, I mean, by day, Dom and I are both web developers, so basically at this point, pretty much the only reason why we want to do random is to like generate credentials and that kind of thing, and there, like, repeatability is not a valid not a useful property, right?
Game developers use random, I'm sure, like way more than web, all the time. Yep. Honestly.
Well, I don't know. Have either of you seen like the crazy like Wind Waker speedrun people? Where there are puzzles in the game that are random,
but they're like actually gaming the seed.
Yes,
they've like figured out the pattern of the random seed to play the game better, which is
I don't know if I've seen Wind Waker, but I've seen some runs like that where you're like, oh, if the first thing I do is I get this drop followed by this drop, then I know I'm on a good seed, and if I don't, I just reset. They do that for Spelunky. I think it's like where you can, it's like maybe like the shop or something. I think you can basically know if your drop is good or not on the tiles.
Right. The Wind Waker random gaming that I saw was unbelievable. Where it's a speed run, so and it's a human controlling the controller, so there's no way that you can like 100% reproduce the exact same input for the game, right? So you're going to be like slightly off when you get to the point where there's like a randomly generated puzzle. But what they do is they basically they've analyzed the puzzle to the degree that they can kind of tell how the random number generator is being used to generate the puzzle. And so it is a non-deterministic speedrun in that like every single run is a little bit different, but they can guess based on the formations of the puzzles, like whatever, like however the puzzle's generated randomly, like each time you retry it, they basically like take the way that the puzzle's being generated and say, okay, we can kind of tell where in the random timeline you are. And therefore, I think the game is like a totally cheap random game. It's basically like it's Battleship.
It's Battleship, yeah.
It's Battleship, right? So like, where the enemy battleships are totally random. But basically because they can analyze like your retries of the random game, they kind of know where along the random timeline you are because it's all predetermined, right? Like it's a little bit like a cheap sci-fi show where like the entire timeline is just determined. It just depends on like where you are along it. And they can basically like figure out where you are. So you basically can guess statistically where the enemy's battleships are over time, right? It's just something like that. Am I communicating that right, Dom?
It's quite a stupid human trick, yeah.
Yeah.
Yeah, those are really interesting. Like some games you can actually understand the entire state of the RAN because you're using it so infrequently. But like this Splunky example, I think it is just you go to the first store and if you get something you like, you're off. Like you play the run, and if you don't, you reset it just because I don't think you can predetermine like all the things, right?
Yeah.
But then there are other things like the thing I've heard people doing a lot now, like gotcha-based games, especially if they have like a new sequence with a random drop.
Yeah.
People will look up like what's the best thing you can get from that random drop, and they'll just wipe their account repeatedly until they get like the best like 5-star random drop, and then they'll like start actually playing the game for the first time. Like, there's a couple of people in my office who will do that if like a game comes out. They're like, I'm going to get the best thing, and it's like, why does it even matter right now? Just play the game. But
yeah. So a game that's really close to both mine and Dom's hearts is Hades, and I think people have figured out how to game the randomness in Hades. Have you played Hades at all, Steve?
I have not, but I've heard a lot of buzz.
Right. It's a little bit like Splunky, right? Like the idea is that it's just like the playthrough is structurally the same, but like the rooms are randomized and the power ups you can get are randomized, right?
I think it's actually right up my alley because I'm pretty into like roguelite and/or likes.
Oh yeah, you should totally play, and then we can do a three-way Hades race. Anyways, that's randomness. I think the third point that gives us determinism is that we have sorted iteration.
Oh hey Jeff, you're drawing behind the faces right now. If you want to scroll up.
Here's another question for your determinism. Well, doesn't matter. Are you using? You're just using floating point for all your positions?
Yes.
Okay. That's another thing I don't know enough about browser implementations to know if that's going to be bad for you or not.
Yeah, it's a good question. I'm assuming because of the fixed time step thing and everything is IEEE 7834. Did I get what is the floating point standard that we're talking about here? I'd say aside from like CPU level bugs, I would assume that all the math is byte for byte the same.
So there are parts of floating point that will leave that, right? Like things that weren't standardized. And it also maybe depends on how that was written. Like if you're writing your code, in C or C++ and you call a POW, like the thing I've run into is different compilers, the way they define like a POW, you might end up with a double, you might end up with a float one. There's the Windows compiler by default turns on, what the heck was it called? Like, it's like this automatic high precision thing, which probably won't trigger because of the doubleness of JavaScript. But like where it's basically being like, no, I know better than you. I'm going to take it out of this, 32-bit register and put it in this, higher precision thing for you. So when we've dealt with that at that low level, we're like, I've had to change. It's like a compiler intrinsic or maybe just to call out to assembly where you're like, actually, let me like flip that mode on the CPU to turn it off. Because web developers probably don't care about this, I wouldn't be surprised if there's drift on that. But if all you're doing is like right now, it looks like your game is probably just doing a couple ads, right? Like float adds and
There's some multiplication going on in there, right?
things in
When
there.
we do like distance checks, I think there's some square roots going on as well. So, there's some juicy math.
Yeah, so the square root would be the one where I'd be like, shrug, maybe that one might break for you, right?
Fair.
Adds and multiplies and all that stuff should just be going down like, your standard like IEEE certified float pipe that probably is the same across browsers, assuming they're not, doing crazy things like putting it in weird registers or something.
Yeah. So there is a possibility then, what I'm hearing is that like between slightly different hardware, different browsers, different browser versions of the same browser, like we could be running into sources of floating point drift.
Yeah, I mean, it would be something that would scare me. It might not be a problem, right? On the game I'm working on right now, it was the first game that our studio switched to Unity for. And I didn't trust C#, so all our combat, which also does like similar deterministic things, is all C++ because we know we can get deterministic floating point in C++ if you like are a little diligent. You can still go shoot yourself in the foot because you can drift out to something that's not standardized.
Right.
But that was one of the reasons. The other reason is like I think.
So did you rewrite all of your own math primitives then as a result to kind of like lock that all down?
We didn't. We just we don't call anything crazy too much. There are people who will just go write a fixed point library because that's kind of the sensible thing to do. Just because at that point you're like controlling everything and you're just going through the int pipeline, which doesn't have as many gotchas.
That's so interesting. So people will still use fixed point math to represent game state these days? I thought it was all floats at this point.
There are definitely proponents of, if you're trying to do deterministic math across platforms, go fixed point, because some people will be like, oh, because floating point determinism is impossible, which isn't really a true statement. It's just floating point has more things that you can shoot yourself in the foot with, because some hardware does interesting things, like even how your like SSE pipelines and things like that. I think some of those end up being different because they're not in that standard.
Yeah. Tom, do you know fixed point representations? Have you ever worked with those?
Hasn't really crossed my path, no.
So the idea behind fixed point is you basically are working on a primitive level with ints. Or basically you're accessing the raw bytes. And so let's say you're on like a 32-bit system. What you would do, I'm just going to cannibalize the whiteboard real quick. So fixed point.
Is it just you have like an exact amount of precision you have access to?
Yeah, you would just say like 24
no
bits, and then your decimal point, and then your 8 bits would be behind
that
the
makes
decimal points.
Total sense, yeah. Okay.
Right. And if you like break the math down, like it starts to make sense where like, I forget exactly because it's been a while, but like for a multiply, you like shift one over.
Right.
Yeah.
And like for a divide, you like the different way and all this stuff. And it ends up being like close enough. Ideally you slap that into like a 64-bit register when you do the math, so that as you're shifting, you're not like just shifting all your numbers out of range.
Yeah.
But
I'm pretty sure
there are still use cases for fixed point for sure.
Yeah. I'm pretty sure Contra 4, which is the game that Steve and I worked on together, or at least one of the games that he and I worked on together, was this fixed point representation for most of the state, 24/8. Does that sound familiar to you?
Yeah, I believe that was all basically fixed point across the board.
Yeah. Sometimes you'd go into 16/16 if you needed more crazy stuff, and then like the conversion back and forth was a pain.
Yeah, but when you're like, oh, like having 8 bits of precision to shift between like an entire pixel, just so you can like do it slightly slower, like that's a ton of precision, right?
It's a lot of precision. Yeah.
Now, when you go down to fixed point for, I want to say like DS or something uses fixed point for 3D, so you have like very low precision on that, and it'll jitter.
Yeah.
Because you don't quite have enough, especially if you're doing a bunch of multiplies on it. But then you have the flip side problem. I don't know if you ever played which game was it? Like Jack and Daxter, where like the last world, when you throw something in your hands, like it'll pop out in this crazy spot because they're getting out of floating point precision because their world was too big.
So how big was the world?
I don't remember, but they were basically getting to the edge of that because you're not at a fixed interval anymore.
Yeah. I mean, it kind of makes me wonder about like games like I guess the big galaxy exploration games, right? Like No Man's Sky or Elite Dangerous or something like that, where presumably you're just like constantly zooming in at like narrow and narrow levels of granularity, because it's not like they're representing your position in the moment-to-moment game simulation relative to the center of the galaxy or something like that, right? You'd just be totally in the realm of like unrepresentable motion.
Did you play Outer Wilds?
Yeah, that was bonkers.
Yeah. So in that game, I watched the making of, and they basically, because their world is too big, you're always at 0, right? Like you are literally the center of the universe, and the universe is moving around you to deal with like that precision thing.
It's perfect for that game too.
It's very poetic that I never finished the game, but it's very poetic that a game about space travel reinvents like the Ptolemaic.
I mean, it's like something that's effectively about like an existential crisis of like, what's it mean to exist? And you're just like the center of the universe. But yeah, I mean, that's an interesting solution. There's obviously some potential problems with that, of like, moving around all your physics objects all the time and all this stuff. But for that game, it worked. Some games you would like shift in chunks, right? Where you're like, oh, I'm moving to the new area, and most of my calculations of like where I am in the big space, whatever the galaxy, could just be, integer sectors. And once you move into it, you have some number of sectors around you, and that those sectors reside at 0, until you move to the next one, and we slide everything over just to get you back in that space.
Yeah, I think that's exactly how I imagine like the No Man's Skies of the world will do it, right? Like your floating point position is just you in the neighborhood, and then wherever you are is probably some nested number of integer coordinates or something like that, right? Yeah. Okay, cool. So that was floating point drift. It's possible that we have an issue with floating point drift. It sounds like the way around that then is maybe to get back to, I think it kind of recalls this problem where like it doesn't matter if you drift if the server can just tell you what the deal is, right?
Yeah, that keeps coming up as a big alarm in my head. Like we actually should be sending some authoritative state back to the clients as well.
Yeah. So for a little context, our game I'm currently working on does do basically deterministic simulation, but we have the concept of like the snapshot that you send back, because both like our game doesn't require people to join for the thing to start. So like combat can just like kick off because two AIs start fighting, and then you can like join it, right? So we can snapshot the entire thing and send it over. And because we're using floating point to kind of get rid of some of the either speed issues of doing a bunch of fixed point math, but also just like maintaining that library, we can actually detect when the like floating point, not exactly floating point, but like when our snapshot state between client and server mismatch, and then we can send snapshot over. So even if our floating point was to have a difference, like a drift because of some difference in compiler platform, we would detect that and send something over. It's not great because the snapshots are big, so you don't necessarily want to send that over all the time, especially if you're like over a WebSocket or something, right? Because now you're just like inundating the WebSocket with this data.
Right.
But yeah, we do it for multiple reasons like that.
Yeah, is it like wild that we're actually doing this? Like every frame is a message from the client and a message from the server. Is that like, to me it feels, as a web developer, it feels like a lot of data back and forth, and I worry about us like keeping track of it and catching up and people falling behind like your client did. Yeah.
I believe most games do not do that for those reasons, right? You're just inundating things with traffic and all that stuff. On a WebSocket, I think it would scare me even more. Because now, like, you know, just spiral out of control, right? Where everything's just waiting behind everything else. It shouldn't be necessary to send it that frequently. You can bucket things up like that. But it's probably a good way to like prove it out, right?
Yeah, but I think the question there is architecturally. There's a more fundamental architectural question, I think, which is that we are sending inputs, right? Whether we send the inputs at the end of every frame or we wait for 5 frames and then send 5 frames worth of inputs, there's like an engineering kind of like conversation you can have about which is better. But from a kind of like simulation point of view, you are still like receiving those inputs on the server side and then simulating them 1 frame at a time, right? Like ultimately, the simulation effect is going to be the same, which I think. And so I'm not trying to dismiss the point, right? Like I actually think I think it's an interesting trade-off to sort of examine. Like, is it better for us to batch our kind of like input payloads into one giant payload and send it over for whatever network, whatever observed properties of the network that we're seeing at a given time. Like, it may be better to do one thing or another, right? But I think one of the big questions that I would love to chew on a little bit is what happens on the client when it receives basically input from this, or it receives the state from the server. So the situation is that the client is, let me redraw a little bit what's going on, I guess, for client A here, because it's kind of like scribble. And I think that'll maybe help me explain the problem a little bit more clearly. I'm going to erase my beautiful fixed point diagram, if you guys don't mind. So I'm going to use red to basically describe like known authoritative state. And I'll use green to mean stuff that is just simulated on the client, but it's predicted. We don't know if it's real or not until we get confirmation from the server. Does that make sense? I probably don't even need that many. In fact, let me enlarge this so it's a little bit clearer. And let's even just have 2 frames, right? I think that's probably enough to explain what's going on here. So, and let's just actually call this frame. This is frame 1. This is frame 2. And this is frame 3. And let's say that the server, we receive a server packet at the start of frame 3. That I need more frames than this. Sorry, I'm gonna just give myself 1 more frame. Let's say at the start of frame 4, we receive the authoritative server packet for frame 2, and that's just like all of the inputs from all of the other clients. It will also include the input that this client sent for frame 2, right? Or it may not include that because this client was slow and didn't make it into the window that buffer time that the server was accepting, right? And in that case, essentially the input that this client collected on frame 2 just didn't happen, you know? So what we do in this case is we actually will snap back the local client state here. And then what we will do is we will replay frame 2's input based on the server state, right? And then what we're going to do is we're going to take the input that we buffered for frame 3 and play that over the top of that, right? And this gets us back to like where we are with frame 4, right? I was actually wrong. I didn't need frame 4. Yeah. Does that make sense so far, Steve?
Yep.
Okay. So I think the issue that we're running into right now is the number of times that we have to do this kind of like replay thing, is basically however much ahead, however long this client input buffer is. Right? It could be kind of arbitrary, right? If the client is just kind of like simulating its way away, and then it receives a frame from the server whose frame number is like 20 frames in the past, you basically have to resimulate 20 times.
Right.
And if the server is doing this if the server is sending this data every single frame, again, it doesn't actually matter how frequently the server is sending this data, but basically like this amount of like, well, actually it does matter, I think. So that's interesting, Dom. Basically, what we have right now is that the server sends out its packet of input, authoritative input, every single frame. And if, let's say you only have one client, and let's say that the server is always waiting 15 frames before it actually, 15 frames worth of buffer before it simulates its frame. Mm-hmm. This is the situation we have right now, if there's only one client connected to the server, is that for every frame that the client simulates, it actually has to simulate 15 frames because it receives the server state, winds the state back, and then because that state was 15 frames in the past, it has to basically resimulate the last 15 frames again. Then you get to the next frame on the client. It receives the input from the next frame that the server happened to simulate, which is whatever the previous one it did, plus 1. Mm-hmm. The client rolls the state back 15 frames and then resimulates again. So you can see how the situation we're in is like we're basically like having to do a ton of resimulation, right?
There's actually a good talk on the Mortal Kombat rollback code. It's probably worth checking out. But they basically, when they're in debug mode, they have their like buffer size. I think theirs is, I forget, like 7 frames or something. But in debug, they basically always roll back because that's kind of the worst case CPU load. Right. So if your game barely runs within 1 frame, but the way things are happening, you're always rolling back 10, then you get into like the death spiral, right?
Yes. Yeah, absolutely.
Now, if your game can do 10 frames at once, like that's pretty good already, right? Especially
right.
JavaScript, right? But I do think you need to take that into consideration, right? And then if you are sending that snapshot literally every frame, then you're never going to have those calm frames, right? Because you're, if you send the input like every second,
yep,
and catching up from that, takes less than a second. Like maybe you'll eventually like catch up on your actual frames before you get told to like redo everything again. But then again, like if you're sending it less frequently, you potentially have to roll back further, right? Because it's going to be even more wrong at that point.
Yeah.
Here's a question: are you predicting input at all? Because there are some models where you're like, well, if the enemy client is hitting D on the keyboard in my last confirmed frame, the likelihood that they're hitting D the next frame is very high.
Yep.
So you can potentially do a thing where you're basically letting confirmed input be used as the next frame input. So when the new frame comes in from the server, you might not have to replay everything because you'll look at it and you'll have predicted the right key, right? So you're rolling back like half as far.
Interesting. So we don't do that prediction now for foreign clients, right? Like, so like if I'm client A, I'm not going to like kind of dead reckon client B's like input, although we can do it. But I think one thing that you said, yeah, we definitely considered it. But one thing that's interesting about what you just said to me is actually that we maybe don't actually have to do a real rollback. Let's say you only have one client, right? And there your input actually should basically like this, like unless there's a network problem, the server should be basically parroting back the input that you sent the server, right? It could be the case that we don't actually even have to physically do a rollback in our state. What we do is just like compare the input that we receive from the server to the input that we recorded. Start with the last known good frame, which is 15 frames back, right? And then just like notch it, like just like basically rather than resimulating, we just compare inputs frame by frame. And as soon as we hit a discrepancy, that's when we need to start the resimulation, but no point earlier.
Interesting.
Right. And I kind of feel like that's what you're saying, Steve.
Yeah, that's basically what I'm saying. Is like, if you let the input dead rec in, which like most people don't toggle a key within a frame, right?
Yeah.
Especially for, this where you're like mostly moving in a particular direction for a period of time, right? I'm moving up and to the right until I get around this barrier, and then I start going up. Those are going to be pretty similar for probably several frames. So that would reduce your rollback for sure. Obviously, if you're letting there be that rollback window before you drop off the input, your worst case is still a client that just gets in under the wire every time. So worst case, the performance you need to make work for your game is that worst case amount. So at the end of the day, it's like, well, it helps, but you should really debug in a fashion when you're not using it.
Right.
But I mean, the thing to note there is, like, even in the Overwatch talk, it's not as I recall, it's not a full deterministic complete rollback solution, right?
What do they do?
So as I recall, they're mostly deterministic, but they do send snippets of world state back at some cadence, as I recall.
Got it.
Because they're not structured around that full determinism, and partially I'm sure that's because you can disconnect and join back in, and they need to send you a state anyway. Partially that's I assume, I don't remember if they covered this in the talk, but for a multiplayer game that's super competitive, you don't necessarily want to send the entire world state, like wall hacks and stuff, right? Like ideally you tell the player that someone is coming out from behind the wall the instant it happens and no sooner, right?
Yeah.
Because now a wall hack doesn't work because that information is not even on the client yet.
Right.
Obviously, you need to tell them a little bit before because of latency. So you'll end up like doing determinations of like, well, they're not going to be visible for some period of time, so let's not send that over, so they don't have some wall hack advantage. So you start to get in things like that where you like maybe you don't want every client to have the full state. Now determinism based multiplayer is like super popular in fighting games because like single screen game, right? Where you want the minimal network traffic and the minimal state being sent so you can like have super snappy stuff like that. Now it's possible in your game, like you're maybe a little bit closer to like the FPS model where like if your kinks don't collide when they're moving and all that stuff, like you could potentially only replay the movement of the one kink, right, that got the input back. It gets a little weird if like you have destructible terrain, right, and you're like, well, do I need to roll that back so I can't move through it and like all this stuff? So
yeah,
it can get a little dicey there depending on your case.
That's kind of how we ended up on this, where there's the destructible walls and we were concerned about pushing the player back at the wrong moment or missing some potential motion.
Right, and in that case you have like a bunch of projectile attacks, so it's like it's a little bit harder. You can't just store the state of the tiles and roll back just to do the hit scan on the frame that someone shot before playing them, driving through it, and all this stuff. So
Yep.
I think it kind of makes sense how you arrived at that simulation, like deterministic. Yeah, but I could see something where you're like not rolling everything back. I assume are you like copying the entire state of the
That was actually the question I was going to ask. Was essentially like, if we go back to sort of the scheme that we were talking about before, where rather than doing a full rollback, what we do is we compare inputs, right? We say, okay, we're going to go back in time, but we're going to compare inputs, and only roll back to the point that the inputs diverge. And the optimization there is it saves us from resimulating frames that we didn't actually have to resimulate.
Yep.
But the implication is that you can arbitrarily roll back not to 15 frames ago, but to 10 frames ago when the inputs started diverging. And that's not the architecture that we currently have. The architecture that we currently have basically acts a little bit like a relational database. Maybe that's meaningless to you, but basically the idea is that the last known good state from the server is our kind of like committed state in the database. And then everything else is happening inside a database transaction that hasn't been committed yet. And that includes like the however many frames that we're doing prediction. And as soon as we get server input, we do a rollback, literally in the database sense, where we just snap back to the last known good state. And so we don't actually have the copies. We can't do an arbitrary snapback to like 10 frames ago because like the only thing that we have is like 15 frames ago. And the reason why we do that is because it's just super expensive to copy data in JavaScript. Because currently we're just using like, we're not like heavily class-based, and more our object, our like game state, like our components and stuff, they're all like plain old data, like plain old JavaScript data. But that can still mean like nested stuff, right? That can still mean like an object inside of an object, which also has an array inside of it, right? And cloning all that stuff is essentially just like a tree copy at that point. And so it can actually be really expensive to kind of like straight up clone game state frame over frame.
Right.
Well, I'm curious, actually, in the C++ world, is that considered to be like a hard thing to do, or is that super trivial? Like, I just want to like make a Xerox copy of the current game state and just like do cool stuff with it. I
mean, that's a complicated question, I guess. It's really easy to structure a code where that's really hard, right?
Yes.
But this is why you'll encounter game developers such as myself who are like, not necessarily OOP fanatics, because you're not thinking about the data anymore, right? Like, it's pretty easy to just be like, I'm going to use like, STL, like do a bunch of lists and memories everywhere. Like at that point, you kind of, it's probably a little bit less of the same problem as you're talking about because it's not an interpreted language. You don't have a bunch of crazy overhead from that structure as well. But you have made it a lot harder on yourself, right? Versus if you're like, I don't care that it's objects. I'm just going to make some structs and make some arrays of it. I'm going to densely pack it, and I'm going to do a mem copy, potentially using like, DMA sort of calls straight to the OS, right? That can be blazingly fast. In the grand scheme of things, obviously, if your data structure is really big, it's not a great idea to begin with, but you can start thinking about that, right? Where you're like, my entire game state fits in, I don't know, like 1K or something. And like, I chose everything very specifically that I needed in there. And I'm just going to copy that, to the next frame. If I need to roll back, I just, do my like current validated frame, like pointer to it. And I'm just start running my frame on that old data. But that's a thing you can definitely do in like C++.
I've thought a lot about how we choose to serialize our game state as well, and like what is actually modifiable versus what is our objects. Because like, I feel like we care about health and position and existence in terms of inputs, but not necessarily like, wall collider hitboxes because they're really not changing. So there's a lot of, I feel like we could actually serialize our changeable game state to a pretty small set of data and maybe easy to message around if we have to put a lot of effort into that though. It's something we haven't written yet.
I'm trying to remember, JavaScript strings are immutable?
They are immutable, yes.
Okay. I was going to be like, well, if they're mutable, then you could start doing weird shenanigans, right? Where you're like putting your map information in like a string, but if they're immutable, you're kind of screwed, right? You can't like maybe like I'm trying to remember what other data structures like JavaScript has. Like, does it have byte arrays, like int arrays, like something you could?
Array. Yeah, there's a thing called a uint8 array, which is just like a fixed it's on the heap, but you initialize it with a capacity, and then you can just write bytes straight into it.
Right. So I'm thinking like a data structure like that might be fine. Where you're like, oh, okay, cool. Like I can copy those. I can keep 10, 20 frames of them. It's pretty easy to index into them. Like I only needed U8 worth of data for map state, and then that becomes easy. And then you're like, well, what else is there? Like the player on top of that, and that can be like a weird JavaScript copy something, right? And that might allow you to do the partial rollbacks because you're not doing a database overlay on top.
Yeah. Now, the thing that I've thought about with that in terms of JavaScript is like, okay, yeah, we can just make like a uint8 array, right? And I was actually talking to somebody at work. It turns out that Slack is a big. We don't work on Chromium super directly, but we're like heavily invested in Chromium because that's actually what like runs the Slack client on the desktop, right? That our like multi-platform strategy is to use Electron and just deploy a web app to basically every single different OS. And I asked some of the Chromium people like, hey, what can I do in JavaScript? I didn't tell them that I was working on the game or anything like that, but I was asking them game questions basically. And they're like, well, what about the uint8 array thing? And I thought about it for a little while and I was like, the problem is that you still need to deserialize your data from the byte array into something that your simulation can understand. So it feels like you're paying the cost of the copy, like the slow JavaScript copy anyways, by doing like a constant serialization and deserialization, right?
Oh, because you can't directly index into it, right?
Yeah, I can't say these 4 bytes of this uint8 array is actually the float 32 that I want to work with right now.
Oh,
like,
yeah, I see what you're saying. And there's no like int 32 array or something.
No, and so C would let you do that, right?
Yeah,
C would basically definitely let you just say like, okay, by the way, the next 32 bytes actually this struct, which is really nice.
And then I'm trying to remember, JavaScript is the one where like an array is kind of not really an array, like in the
yeah, it's like an array is actually an object with integer keys that
it's like syntactic sugar on top of a append of a name or something, right?
The uint array might not be, but the normal array I think is.
Yeah, but like a normal array, if you're like, I'll just pack it in a normal array, it doesn't really matter because you can still copy it out in the same like slow fashion.
Right. I'm actually not sure what goes on under the hood for a normal JavaScript array. I think probably.
Yeah, I'm sure like depending on the implementation, like some whatever V8 or something is probably like does some crazy optimization, but.
Well, what I imagine happening is that your array is probably a fast numerically indexed vector up until the point when you try to set an actual string key on it, and then it probably has to transform it into a hash table. That's sort of what I imagine it doing, because the semantics of JavaScript allows you to do that, right?
Right, where you're like, oh, suddenly this thing that used to be an array of ints, I just like slapped a string in here, and also I added an object, and like now it's an array of arrays. You're just like, oh my God,
exactly.
What are you doing?
Exactly. Yeah. So the fact that we have to do this serialization and deserialization against the uint8 array, to me, means that we brought the copy problem back, only in a kind of different form, right? With JavaScript.
Yeah, I mean that's probably true. Like if you could fit your data into like a single U8, like you really only need 256 values for your map state per square, which honestly is a lot. Depending, like if you wanted the bricks to like catch fire and then now they have like some health value and like additional stuff, maybe that's not great. But like if you're just grabbing one value out and you're not like grabbing values, appending them, doing some crazy like bitwise operators in JavaScript to like reassemble an F32, if it's really just pulling out a a U8 and doing a check on it and then writing back something.
Yeah. It's just tricky because I just think of like even just basic situations like your tank is driven halfway between square A and square B, so it's got a floating point position, and you want to do collision detection. I got a bullet flying near that tank. Did it hit the tank or not? Right? And you're gonna have to do that kind of check, that kind of logic every single frame, right? And so it feels like all of those variables need to be like high fidelity numbers that are easy to work with. You know what I mean? And
oh yeah. Like I think I'm only picturing it for the tile set.
For the tile set, yeah.
But then you start to be like, well, how am I storing the bullets? How am I storing the player? How am I storing like this thing and that thing? And then you're like, oh, did you just make it worse and more complicated and slower by trying to do partial rollbacks?
Yeah.
Especially since, as we're talking about, like, you should be probably operating around your worst case, like full rollback.
Yeah.
And fitting that in your like 16 milliseconds or whatever frame rate you're trying to do.
Right. I mean, that's an interesting point you just make, which is that like whatever tricks you do to kind of like even batch together frame over frame inputs into like a single packet that gets handled by the server all at once or handled by the client all at once, you still need to be prepared to deal with worst case, right? You still need to be prepared to deal with the one frame that like has the one simulation frame that actually has to deal with a bunch of logical frames because you got a bunch of data that you needed to chew through, right?
Right.
Yeah.
Yeah, because like if none of the hardware you run on can do that fast enough, and
doesn't matter,
slowing down means that you're going to start sending things late or getting things late, then yeah, you're basically, again, you're like death spiral, right? You're like, there's no recovering from this.
Yeah.
So why did I even allow someone to roll back 100 frames if we can never not death spiral from it, right? Like, we should start cutting off the inputs at 10 frames or something, just so that you throw it out and you get them going again. And then, like, at that point, like, getting, is your snapshot small enough that you can like get it and apply it and then catch up your frames fast enough is like also a concern, right?
Right.
Like if that takes you, 5 seconds to get and apply and get rolling again, and you're already behind,
right,
you're just screwed.
Yeah.
Damn.
So I'll throw some crazy numbers at you. Like, if you watch the little like blue debug text in our game, in fact, let me fire it up just to give you the example. Give me a second here to work the keys. And actually, what I want is only one player because I'm selfish.
Oh, I was going to connect.
Sorry, Dom, not today. No, I'll turn back 3-player on again. We can all play together. But I just want to. In fact, I'll even run it from here. Gotta get zoom out of the way. Here we go. Oh, are you kidding me?
Abort.
Okay, so it's kind of hard to see, but if you tick MS, it's the 4th line down. That's the thing that we want to look at. It already takes us like 6 milliseconds to simulate just this, and there's nothing in this game. Like, there's not a huge amount of state.
Yeah.
Closer to some of these turrets, we have a little bit of spatial indexing to make sure that like entities that are far away don't get updated. Like, we're already at 10 milliseconds.
That's a single tick?
This is a single tick. And the reason why is that includes the resimulation that we're doing, because, again, like the client is essentially always 15 frames ahead of the server. For every single frame that the client simulates, we actually have to resimulate basically 15 times, right? This is the classic problem.
Okay. So that's not one tick. That's all the ticks for it.
Yeah. It should probably be like update milliseconds, because the update involves like 10 ticks. The ticks aren't all semantically the same, because some of them are prediction and some of them are reconciling the server state, but like essentially it's full simulation.
So is the server sim MS? That's a single.
That's a single.
That's a single tick.
Yes, because the server's not doing any rollback at all, right? The server is collecting inputs. Whatever it gets to dictatorially says that's what happened, and I'm just simulating this. Yeah.
So, but you said you're rolling back like 10 times?
We roll back once, jumping back in time 15 frames, basically.
Okay. Okay, that's interesting that it's not like a straight up multiplier on a sim.
It is
server
interesting.
sim.
Yeah, it is interesting.
Does that structurally make sense to you, or is that more like a cache miss sort of thing?
That is a good question. What would either, like, there's some minimum overhead that we're paying, right? Like perhaps there's some expensive thing that takes up 1 second.
Right, like maybe that's like frame finalizing of your relational database thing.
Something
right?
something like that.
It
Yeah.
only happens at the end of the final thing, but that happens like every tick for server, but not every tick for the client, because the client does like 15 and then like finalizes it.
But I guess maybe one of the reasons why I think you might be asking is that, like, could we be overlooking something obvious, right? The fact that like this isn't like a straight linear multiplication means that we could just have a straight up bug, right? That's causing us to like.
Right. I mean, it's like if you can rationalize it, maybe it does make sense, but it is a thing where you're like, okay, like, does that make sense?
Yeah. Yeah. Totally.
Like it might, maybe the server sim and the update, or in the client ticks, I don't know, they hit the cache that one time and they're mostly okay after that, and until the render loop of however you drawing this, if it's using like the DOM or something, like who knows what happens there. Maybe the cache flushes and then you come back around again.
Well, that does, I guess the implication is that, it's a 0.6 of a millisecond should be our single tick based on this, because that's the delta. That's 14 times the difference between server and client tick here.
Yeah. And you know what else is funny? This is kind of neither here nor there, but I'll point it out because it's just sort of tangentially related, is that, like, you see update FPS, red enter tick MS, that is like far below 60 at this point, right? Like our render FPS, which is like hovering just like a couple hairs below 60, that's our like update callback locked to the vsync. So we are getting basically 60 there. The update FPS should be 60, and if I actually drive away, like
drive
positionally,
north,
it climbs back up to, if I move away from things, our spatial indexing kind of like gets into, and so now we're a lot closer. So basically, the fact that really the tick MS again is like, it's like a lot of simulation. The fact that it's like far less than 16, which is 1/60th of a second, means that I think what we're looking at is like thread, like core contention on this whole computer, right? Basically, as soon as we creep upward per frame time, if I get a little bit closer here and like the frame time gets higher, it has an outsized impact on our actual FPS, because I think what's happening is that like the browser is not scheduling this like 60 frames per second update call at actually 60 frames per second anymore, right?
Right, and that's really interesting. So that's like something in the callback mechanism or some other thing that.
Yeah, the event loop in the browser somehow it either like has to deprioritize that callback because it's just not getting the CPU budget from the OS or something like that, right? It's just not getting, like, it's like fighting against the OS at this point. Because theoretically we have 16 milliseconds of time budget per frame, right? Like this 10 millisecond timing that we're seeing right now should be under strictly 60 FPS, right? Just for the update.
Yeah, like if you're in a thread that's getting consistently scheduled and you have full control, like,
yeah,
you should be perfectly fine there, right?
But there's a ton of other things going on my computer right now, right? Like I'm on Zoom, I'm doing all these things, so.
Right, and who knows, like your render FPS is hitting, so maybe that's.
But I've got 12 hyperthreads on this thing. I should be able to like I should have a little bit of headroom. What did I spend all that money for early in the summer?
And that's a good point. To your comments of like, JavaScript is kind of a weird beast with how it handles threads and or doesn't, right? Like like what's happening internally there, right?
Yeah.
Yeah, I've been very interested in investigating web workers because that's actually the only way to get a second thread in JavaScript. But then we have to manage another set of messages to hand information between the render state and the simulation state in a different thread.
Yeah.
And that's a whole different arcane interface. WebSocket's but worse.
Yeah. So web workers, like Dom was saying, is the way that you get true parallelism in the browser, because otherwise, if you just like write JavaScript code, it's all running single threaded. Like the interpreter for the language is single threaded.
Right.
And there are only certain times where it'll yield execution to a different line of code, like elsewhere in the same source. But like with web workers, you actually get true parallelism. There's no shared memory, right? So you have to communicate by serial, whatever messages you want to send across the, like between these worker threads, you have to like serialize and send over, right?
That's heinous. Like,
yeah.
Yep.
Because they didn't want to deal with any. There's like no locking primitives, right, Dom? I don't think there's any kind of like. There's no synchronization.
No, you just get to send and post messages and hope that they arrive at a reasonable time.
Like WebAssembly doesn't have threads yet either, right?
That's a really good question. Do you know, Dom?
I have no idea. I haven't touched it yet.
I don't know how it deals with threads, to be honest. Because like WebAssembly is really mysterious to me. Because like if you make a syscall in WebAssembly, what does it do? Like, does the browser respect it or not? Like I don't actually know.
I actually think the exposure of syscalls is actually one of the things they haven't quite gotten done yet.
Yeah.
Like I'm not like super up on that stuff, but I think like all the POSIX stuff that you would normally have if you had a full-fledged language, threads included, is not like, it's not in like the WebAssembly MVP deliverable, but I can't say that I spend too much time looking at that. It's a mild curiosity because I feel like it, at least for a game developer, like it starts to make the web sound a little bit more tractable. Because like stuff like this, I'd just be like, well, freaking let me run arbitrary code and give me some like memory access. Like all this stuff ends up starting to be solvable, especially if you give me threads in the process.
Turns out WebAssembly has threads. They are web workers with shared memory. So the perfect combo.
Okay.
So how does it know? Like, I guess WebAssembly, there's some basic concepts that are missing in my brain. Because if you like the idea behind the whole selling point of WebAssembly is I can just take a C program that's written somewhere and don't have to rewrite it, don't have to like take a hammer to it, and in principle run it in the browser, right? That's the big selling point.
Yep.
But what if it has to what if it has to like open another thread? Normally you would do that by making a syscall, right? Like you would make a syscall to spawn a new thread, and so. Does WebAssembly
if you use P threads, you're fine.
Okay, so it has a P threads interoperability layer.
Yeah.
Okay.
And if you don't, who knows? If
you
don't, it probably doesn't work.
IO is the same, right? Like if because like you can run Doom and Doom has to open WADs, like you can. So presumably it has to like do file IO, and then that gets intercepted by V8 or whatever runtime is running, right? And then saying like, oh, actually, I'm going to sort of magically do a special thing and make sure that you're observing the security policy in the browser or whatever, right?
Yeah, I think anything that starts to break that browser security layer is the suspect stuff right now. Like I don't think you can just open like a UBP socket.
No, wouldn't that be nice?
Like that'd be ideal, right? If stuff moves in that direction or you're getting like close to that, then like it starts to become kind of a compelling way of delivering software, like as a game developer. Like you'll probably never quite be to the point you're like, oh, it's good for native apps, but like if WebAssembly is sane, gives you threads, gives you some underlying access, lets me do that in whatever language, and actually caches the compiles, and now I don't. Yeah. Especially, I mean, ideally, like Apple or Google would be down with you delivering stuff in that way if it was properly sandboxed. And now you're like, look, like releasing a new client on iOS is a scary thing, right? Like,
Yeah.
it's not like the web where you're like, oh, crap, we messed up. Okay, let's just like update that JS file and we're good to go. Hopefully we didn't, nuke the database in the process, right? As long as you didn't do that, you're like, fine. Like this, you have to like get your build ready, submit it, click the emergency button, hope that Apple gives a crap about your thing being down. That's like super scary, right? So you like, web world, everyone's like talking about do things as fast as possible, deliver software every 2 seconds and all this stuff. And games are like, well, we need the performance and we can't really deliver stuff via, the internet because the platforms don't let us, frankly. But if stuff like this allowed them to feel like we weren't going to subvert their OS because we're going through this sandbox mode, and the main price we're paying is just like whatever compilation stuff, maybe not being quite as fast as like a natively baked binary. That sounds like something I could totally jump on like in the future. So I hope it gets there because I thought like looking at you guys try to do some of this stuff in the intro, like, oh wait, single thread, oh my god, okay. You can't make an array.
Yeah, well, we're getting into full like Valley gossip right now, but Dom, I'm curious. Like, I think the future that Steven just described, wouldn't that scare a company like Apple, for example, right? Because like Apple, like it seems like their MO is to very much have a closed down platform, but like what is their what like would they not seem to be aligned from a profit motive perspective against a WebAssembly future, right? Like and Steve, I imagine you're talking about literally delivering through the browser, right? The browser being the vehicle of communication. Because
I mean, potentially, like obviously if the platforms like exposed everything through the browser, yeah, probably, right? Like if you could get code compiled to like 95% of what it would have been if you delivered it natively. But now everything's open. Like that'd be cool. But if they don't expose everything, then I think it would be like a native wrapper around some like code that you're delivering this way, right? Like the iOS stuff is like no DLLs, right?
Mm-hmm.
Right.
Like you can't even do a DLL baked into your IPA, right?
Like, I don't think so.
Like, like static libs only, like everything self-contained, no shenanigans. We don't want people to be able to, jailbreak and swap out a DLL or something. That I think for them might be more tractable if it is going through their sandbox, right? You're like, it's kind of like they don't let you use your own like browser stuff, right? They want you to use theirs for, I assume, similar reasons. Like at that point, I would deliver stuff like that, and then maybe I want to use Apple Payments and some other stuff that's like built into the phone, and there's like a native app wrapping around this, so I can use all the fanciness.
Yep.
Like that to me like sounds palatable.
I mean, that's actually my day job is working with React Native, and it threads exactly that loophole where most of the app runs inside Apple's JavaScript interpreter, and they've just written a bunch of native interfaces to like be able to call Apple Pay from a JavaScript session. But actually I can ship code updates via an HTTP push to all my client apps, which is really nice to be able to like bug fix without going through Apple.
Oh, interesting. And so what's the dividing line? Like what?
I'm in a JavaScript runtime. I can update. I can curl and save a new JavaScript file to like my app's sandbox documents folder, and that replaces my app runtime in the JavaScript context. But like, if I need to like tweak an Apple Pay screen, I have to like ship a new app update.
I'm actually flabbergasted. I had no idea that you had that level of flexibility in iOS.
And they're totally okay with it because you're using exactly their runtime. They know what's up.
Okay.
They won't stop you.
Yeah, and it's a weird thing because the way their terms of service is written is like, technically, they could probably pull the rug out from under you at any moment if they really wanted to, right? Because you're like, oh, like, you're delivering code. Okay, get out of here. I mean, obviously, they've historically done random things like that. Sometimes justified, but not written down in a way that you understand it. But sometimes I think just because like their business has changed and they switch some stuff around. but I tend to get why they want that stuff sandboxed, like not doing DLLs and stuff. But yeah, it makes it real hard that we can't just hot load that stuff.
Yeah.
And their recent terms of service change, where it's like kind of targeting things that are basically just like that React Native wrapper that doesn't use any of the iOS stuff, right? Like if you didn't have Apple Payments or some other stuff that's, from the native SDK, that like they're like, get out of here, go to the browser, which is like super interesting.
Well, and the thing they'll get you on is if you ship an update and they notice and it like changes a big feature, they will like come down and be like, you need to ship an app update. You can't just code push like version 3.0 your app to users.
Interesting.
If they notice you're not, but like you can bug fix and you can like A/B test.
Yeah, and I'm pretty sure there's a bunch of game developers that like will do like their UI or something in a web view and update it, and it's kind of not terms of service, and it's kind of like no one says anything, and you get away with it until you add like V-Bucks to your store.
Right.
Well, and they have a whole system for shipping level updates to games where you can download specifically game data whenever you want to, which I think is probably how like Fortnite was delivering some of that stuff, right?
Yeah.
So on the flip side, they forced Microsoft to put their streaming service in the browser, and somehow they did it. Like Safari is where you do xCloud on iOS.
Wait, what is xCloud?
xCloud is like the PlayStation Now of Xbox, where it's like you or Stadia or Amazon's whatever their thing is called.
Yeah.
But it's 100% runs in Safari. You connect a controller to Safari on your iPhone.
Maybe this is all for naught, the whole WebAssembly dream, and everything is just going to be streamed to us in the future. I'm hearing like actually people coming out of the woodwork and saying that they kind of like Stadia now. So like,
interesting.
Maybe that's just the.
I haven't heard that yet. But the thing I always thought was the nefarious Stadia plan, and it does. Having talked to some of the people occasionally, I don't actually think this is their nefarious plan, but it should be. But basically, Android becomes like, and Stadia is future Android, right? Where it's you just deliver handsets that can, like stream the video and inputs pretty quickly, and like now instead of being like, hey, Samsung, can you guys really just like use vanilla Android? They're like, oh, it's just a stream, and it's great. And now
it's just a screen with the radio on it, right? At that point,
I assume this is.
And now you know everything that anyone taps on because you're getting all the input events.
Oh man, yeah.
I assume that's actually one of the core reasons for the push for 5G. In fact, is like I have no actual need for like more data and lower latency in my mobile app usage unless someone wants to be streaming me like the entire UI.
Yep.
So we'll see. But I bought a 5G phone, so.
I won't even turn on Siri because I'm just worried about like my like voice commands going on the internet. Like I don't have any like voice operated things, and so contrary to like what we were just talking about, I'm kind of waiting for the for devices to be powerful enough to run the ML model for voice recognition, because I just don't want anything going over the wire. I just want it to know. It should be smart enough to know.
That's fair.
Yeah. All right, so that was a little bit of a rabbit hole. Where were we?
Okay. We got 10 minutes left, ish. I mean, we can go as long as we want, but I want to respect the time slot. I think the question I have on my mind right now is that like we've been talking about like we've been dancing around. I think the one question that I think was core when I thought, let's bring someone on who knows what they're talking about to kind of talk about this, is like, is a fully deterministic simulation the way that we're doing it? Have we badly misunderstood the idea? Or are we just fundamentally bumping up against the limits of what the language or platform can give us? And are we better off, rather than synchronizing inputs, having the server say, like, this is the state, or this is at least like a diff of the state from when I last.
Right. Like that's a good question. Like, can you get that over the wire quick enough mean, I guess if you're already kind of applying those diffs to your database, like you almost have that diffing notion, right, of what happened, right?
Right.
And currently, I don't think giving you those diffs would be wildly complicated, right? It's going to be, hey, this block got destroyed or this tree got destroyed.
Yeah.
Probably max case like one per player per frame, right? You have like splash damage, or is it just like direct hit?
Well, we might get to that point.
Yeah.
We'd love to have splash damage.
So
I don't know about you, Dom, but I'm all about the splash damage.
I want this to be much more complicated, and we're just blocked.
Yeah.
Right. So, and even then, like maybe it is somewhat simple. Like maybe the splash damage is more like an all or nothing thing, right? Like it's like a destroy blocks radius, right? So you can just send like the radius over and say destroy everything in this area as like a compression thing.
Yeah.
But maybe it is just like, oh, these 30 blocks changed. Like here's their new state, starting at this time, and then sending the inputs, and all it's rewinding is the players, so it can play them back, and then like applying the time stamped frame changes for the tiles. Like it's definitely possible.
Every time I think about this solution, I still though run into one wall, which is that even if the server's just sending full, like you get like a snapshot at some point, which I think we're gonna have to implement regardless of what we do, because like we want players to just join in the middle of the game, right? We need to be able to have the ability to snapshot. So let's say you're doing the snapshot thing, and then what you're synchronizing is just like every 5 frames, I'm just going to tell you the things that changed, and there's a packet of data that does that, and I just want you to fucking apply it, right? And that's what your state is. That diff is still from the past, right? Like you are predicting on the client side, right? You want sort of smooth, buttery input. You want to do prediction on the client side. You get a packet of data that's a diff from the server that is still relative to where you have predicted in your past, right? And so you still have to resimulate on top of that, right? You still have to say, like, I've buffered my input on top of that point in time. Unless you want to get into this weird situation where you apply the diff that you got from the server and just pretend, even though that it happened in the past, that it happened on the current frame that the client is on right now, right? Like you could do that. I just can't I can't get around, like, if I want things to be like temporally correct, where the server says, okay, here's your diff for frame X, but the client has already simulated the frame X plus 5. I can't get around the fact that we still have to resimulate those 5 frames from when the diff was received.
Right. And
you'll have to pay the processing cost, right?
And you will, right?
Yeah.
But if you're not, in the case of not being fully deterministic, you're basically relying on the notion that even if you're off, that thing will be corrected eventually, right?
Yes.
So you're not necessarily having to do this like crazy full world state maintenance rollback replay thing, right? Like I think that's kind of what I was talking about, the Overwatch thing, where they'll like replay portions, right? Like, I need, like, the projectile is going near this character, so let me make sure that like state is right, because I need to know if it's going to get hit at this exact frame because the projectile is like flying by.
Gotcha.
I'm trying to remember exactly what they said they did there, but I think it was something like they were rolling back intelligently based on their needs, so that it wasn't a full rollback. And so in that case, you're potentially just, this player's inputs came in late, let me like roll that back and replay it. I do think it does get easier if you're able to like copy that entire tile map state easily, because then you can just like, I got a message that said this wall got destroyed, so let me like stamp that in and like recalc those last few frames. And then once I have all those frames, now it's easy to only replay that character's motion through those, right? Because I don't have to roll everyone back. I just have to roll myself back and then go frame by frame checking the new tile maps that are stored.
Yeah.
That's interesting.
And that gets a little bit easier.
There's a Russian doll inside every Russian doll, right? Like, so like so here, you raised this interesting question of like, maybe the problem with the resimulation being slow is that currently it's total, right? Our resimulation currently is like the full world. It's totalitarian, right? Like, and so what you're saying is that there must be a way to like selectively just resimulate. But the principle that I have in my head based on that, though, is that if you're predicting on the client side, you should probably resimulate everything that you've predicted, right? Does that seem like a reasonable principle? So like if there are bullets flying around you, like projectiles flying around you, you are probably predicting it, like their motion, right? As they're flying around.
But if a projectile was fired in a authoritative state, its path definitely hasn't changed. The only thing that would have changed is something interrupted it. But like if the bullet's over like on the other side of the map, like it's going in a straight line.
Yes.
And there's also if that's not deterministic anymore and the server is authoritative on that, at what moment does that matter, right? Does it only matter when it destroys something or does damage to something? In which case, like you'll eventually get the server will come back and say, hey, like you got hit and your health bar and all that stuff changes, right?
Yeah.
So the projectile being wrong or only
I see what you're saying. Yeah.
Extrapolated from a state that is known and like whatever, like, yeah, maybe that's resimulation, or you're like, well, I got one state and I extrapolated it. And if it goes off in the wrong direction, it doesn't matter because the server is going to come back with the right health for the right thing eventually.
Yeah. I guess this gets into, I think, what I would consider to be more of like a software engineering problem than like a pure programming modeling problem, which is that like, it does this simply then degenerate into us having to implement very finicky object by object logic for multiplayer, which is the thing that I've been trying to avoid this entire time, where it's like, where we look at the bullets and we're like, okay, well, for the bullets, we don't really care about it being super precise. And so we can have extrapolated, we can even have something that's extrapolated from a incorrect like last known good state, and that I think what I'm getting at here is we have to like make this like nitty gritty, fine grained behavioral choice about literally every object in the system, which horrifies me because it means that like all of our like gameplay development is going to be bogged down by like all of these like how does this behave in multiplayer type questions, whereas the one saving grace that we have with deterministic simulation is that everything, we can just write the code as if the logic just works. And because it's deterministic.
Yeah, I mean, that's 100% the good thing about input-only deterministic simulation, right?
Yeah.
Versus, like, if you go through, code for, like, Counter-Strike or Quake or something, there's a bunch of, like, is client, sort of checks in there.
Yeah.
Which, yeah, you're making some of those choices, and maybe, you systematize it a bit so you're not having to completely deal with that.
Yep.
But like you could systematize it and say, yeah, like we roll back and we just resim all moving things from the new state. And then after that, like only roll back if necessary.
Right. Does everybody who...
Oop, do we lose Jeff?
I think so.
Jeff,
I think we lost him.
Or do people come to a solid steady state?
Wait, everything you just said, you totally cut out for us.
Oh.
And we were still here.
Yeah, I just got a warning. I just got a warning from Zoom that my internet connection is unstable. The question was basically like, is multiplayer implementation just always going to be this fatalistic enterprise? Like, is it always just going to suck? Like,
yeah, I mean, kind of, right? It's like
Right.
I mean, it doesn't entirely have to, but yeah, I mean, it's kind of a dicey thing, right? Like,
Yeah.
even the idea of like, hey, let's synchronize a clock, right? It's like, that's a hard problem over the internet, right? And there's, NTP and like all that stuff, and there's like ways of doing it and standardized and blah blah, but like kind of not, it's not perfect. So like you layer that on top of like different latencies from different players and rollback and like all this other stuff, like I don't know, hey, you want to make your tile map really 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 freaking big to the point where it's so big that your client isn't like strong enough to roll back that entire state anymore, right? Like what do you do, right? Hey, cool, your rollback solution doesn't work anymore. That's kind of why you end up, and it's a little two-pronged, right? Like you end up not doing it for certain things where you don't want to have that state roll back, right? But like something super simple, a fighter, you end up doing it for, but then like it's weird because you also end up doing it for something wildly complicated like an RTS, right? Because there's so much stuff that you can't possibly serialize all of it over when the state changes.
Yes.
And like maybe if you only saw a small section, you go back and you're like, oh, it's kind of FPS model where we like send you that little tiny section of the world, and like when you get to the next one, we'll send that over because like you don't need to know about all of it at once. And yeah, I mean, I think that's why it gets complicated, because it is this trade-off for your game, right? Like what are the important things that stay right across the network? Like what is your latency tolerance, like all this stuff, to kind of get the optimal thing.
The thing that I'd always heard about I'm sorry, I think I was talking while you had cut out, at least on my end. Didn't mean
Go ahead.
One of the things that I think probably people you and I both know have complained about is like, oh, we had to like bolt multiplayer on when the game was like halfway done, or even more done than that. And that was always like the hard thing. And so I think in order to get out ahead of that, I like encouraged Dom and I to like just like work on it early. And so we've been kind of like on it for the last couple of months, for like almost the majority of the lifetime of the game at this point. And I don't necessarily see a light at the end of the tunnel per se. I mean, I'm not like super pessimistic about it, because I think what we have like is actually the beginnings of something that kind of works. But like, I'm also kind of worried that it's like fundamentally flawed, right? Like we can't get what we want. And at that point, then we're back into a state where we have to kind of like be constantly noodling and iterating. And I kind of wanted to like just have a solved problem and then move on from it, So maybe that's a fantasy.
I mean, you'll eventually get in a good spot, but I mean, there are reasons that big studios have like full-time network engineers, right?
Yeah.
But I mean, you're totally right. Like to jump on it first, right? The retrofitting is really hard, if not, impossible in some ways. Like it ends up being super kludgy. That's actually a pretty good talk. I think it was like the Handmade Con talk from one of the Diablo guys, of just like how crappy Diablo's multiplayer was tacked on. It's why it's totally you can cheat all over the place. But like it worked.
I used to dupe items all the time.
Yeah, item
like,
duping.
Yeah.
That's precisely why, right? Like it's peer to peer with barely any authentication.
Yes.
Like it's not really actually deterministic to the point where I guess enemies could be in different spots on different screens, but like no one notices because you're playing, you're not looking at the other person's screen. But yeah, that talks interesting, at least from like an old time retrospective of like people doing kind of multiplayer in the early days. So here's something I was thinking about your tile map. Are the tiles going to grow back?
Like for walls that you can destroy?
Right.
We have it so you can build walls. In fact, the pre-multiplayer version of the game had like...
It had buildable walls and stuff. And like you could plant trees, harvest trees, build walls. Yeah.
Okay.
Build turrets.
Yeah, I had an idea of if it was like a one and done sort of thing where you could basically have a timestamp of the time where it got destroyed, and maybe at the time when it was confirmed with the server where it got destroyed, and that might simplify your rollback. But if things can come and go and repeatedly, I mean, maybe there is still something there you could do just to like minimize that churn on the data structure and what you need to copy around.
Totally.
I was thinking a lot too, like a lot of we spend a lot of time on like aiming, and there's like a array cast for the turrets to like look and see what's ahead of them. But for a certain set of angles, they know that there's going to be a wall, and actually like I feel like aiming can be memoized in sort of a like, well, we could timestamp when that wall was there, and like for this set of angles we know the turret is done. So there's actually, I feel like it feels like just brute force optimizations to like teach things to be faster.
Yeah.
Yeah, because at that point, like getting the state up to date, if you're not, if you're just sending like events, you're like, oh, the wall is gonna, died at this time, and then you can just put that in there, and when you roll back and you're playing the like, where did I move to logic, you can be like, can I move to this square? Oh, is that thing there on this frame? Yes. Okay, I can't. But like, oh, it's not there on that frame because you're just checking the timestamp. Like that could be an interesting optimization there. Because then, you don't need the copying steps, and you potentially don't need you could do a partial rollback, at least on that one thing. Or I guess you wouldn't even need to roll back if you store the confirmed frame and the predicted destruction frame, and you're just applying that. But I now you said like they can come and go, I can't quite, like I'm thinking if there's some way of still compacting that down.
Yeah.
I guess it depends how quickly they can come and go. Like if there's a window that's large enough where that state is still fine, you're just basically bookending like it being alive or dead.
Yeah. Gosh, there's so much more that like I'm like bursting in my brain to want to talk about, but we're a little bit past time. I mean, the thing is, the nature of the game that we want to create, I think, ultimately looks a little RTS like. Like I think we want to have kind of like you're building stuff, and almost like emergent systemic things happen as a result of that. At least like you can like light something on fire and then like the trees burn down, but you kind of want everything to be like perfect. It almost like kind of, to me, it like at least gut wise felt like the deterministic simulation was the right thing to do for that style of simulation. And yet at the same time, like I think the thing that we need to get around is just like having anything that's expensive at all if we're resimulating so much, right?
I mean, I think you're not off base. Like that's probably where my mind would go like right away. You're like, oh, we have this crazy large tile map. We want, things destroying and coming back and building and like all this stuff. It's like, oh, okay, like let's just make it deterministic. And that's where I'm like, is it really just like figuring out how to do that more efficiently in JavaScript? Like, is that like is that why people are using WebAssembly now? Like, I don't know. Like you like move some stuff over, or kind of the point on like some of your timing things. Like, is it really just like some scheduling contention, and you have more time than you realize?
Yeah.
But yeah, like if there was an easy way to make that tile map just an actual array that can be quickly serialized, or like, then like the snapshot becomes really easy for light join, especially if you could pack the remaining information of like, oh, we can do 50 projectiles at once and like a couple of players, and that goes into that, tightly packed thing as well. Like, I think your solution looks pretty reasonable at that point if you weren't surrounded by the constructs of JavaScript making some of those things slow, right?
Right.
Fair enough.
Yeah, because especially like none of the gameplay logic right now for you guys is crazy, right? Like it's like you could roll back a ton of frames at once. Like if this is in like C, right? And you just have a tightly packed array and you're doing some logic on that, and most of your calculations are against a grid. Like you could make that really fast to the point where you could roll back pretty far in a frame. It's just, can you do that in your box right now?
Yeah. I think maybe one of the things that we need to do is to start thinking a little bit out of the box. Right now, the walls, they're not tiles, they're entities, right? So they're actually like in the floating point space of the world. And so maybe what we need to do instead is allow the hit detection algorithm to be different between shooting at tanks, which can move around in between tiles, versus shooting at walls. And like literally let that be two different loops, two different checks.
Yep.
Right. Because the fact that we have, it's that we have not only an expensive computation, but we have lots and lots of entities, or the components of those entities rather, implicated in that expensive calculation, right? And maybe we need a way to think outside of the box a little bit and maybe like not treat everything the same way, even though they ostensibly kind of seem like, it's like shooting at a wall and shooting at a tank should be kind of the same thing operationally, but then again, there are actually certain things about them that are completely different from a
one's
property
a lot
perspective.
cheaper,
like a wall is
yeah.
never going to straddle two tiles. Yeah, exactly.
Right. Like that's actually really interesting. I didn't even think that would be the implementation, I guess. Like, I was very much picturing like there's like a type ID per cell and maybe like a health value or something, right? And that, like, you know, if you're 500 by 500, or I think it was even smaller than that, right? Like that's pretty tight to pack, especially if like you don't actually have that many types and the health isn't that crazy, right? Like if you don't have that many health values, you know, less than 100 and like only a few tile types, then like that's like a UA, right?
Yeah,
like,
totally.
Packed that tightly and you know, in a sensible thing, like a mem copy of that to, you know, 10 frames, you know, 50 frames of rollback is like pretty trivial. And then at that point you just have your I mean, almost your projectiles, right? Like what type are they? Where are they? You know, do they have health or something?
Yeah.
And then the same thing for your players, and those could all be, you know, pretty tightly packed arrays as well. And now, like if you're able to do that, then a mem copy of the, you know, like a struct of 4 players and, you know, 100 by 100 wall pieces and 50 projectiles or whatever, and just copy that to the next frame when you're simming a frame, or roll back with a pointer. Like, but like I think if I was in you know a language with pointers in arrays like that, I think you're on the right track for the game. I think that bridging the point to JavaScript is the part that seems sticky to me. Because it's not, you know, my domain, but also like can you do it? Like how fast can you do it?
Right. Cool. Well, we're 15 past, so I think we should call it here. This is like friggin' amazing, actually. I'm so glad that we did this.
This was really great. Steve, thanks for joining us. This was super
fun.
It
was super fun. My first stream, and I guess your first guest, so all good.
Yeah. I think I feel a great sense of validation in that, like, we've at least bumped into some of the problems that you were able to kind of like extrapolate from just like a very, very like skeleton sketch of like what we explained to you. But at the same time, like I also felt like I learned a ton of stuff that I didn't know from just these 2 hours. It's incredible.
It's like I think it's cool that bridging that gap isn't too crazy. I mean, it helps that we both watch the same Overwatch. You're like, oh yeah, I've seen the graphs he's drawing before. I mean, some of it's obviously like pretty standard for networking stuff.
Right.
I think I think it's been interesting from my side too, of like, what are, I don't develop games in JavaScript. Like we run, our backend in Node.js for parts of it. So like there's some things there, but that's very like IO heavy, not calculation heavy, as I'm sure, most JavaScript is, right? So it's pretty interesting to see what the problems of trying to do a game in that space, that's not just like, less advanced than like a Flash game, which is like half the JavaScript games you see. So just like someone actually be like, oh, we're going to have like, crazy persistence on the world and network and like all this stuff. It's pretty interesting.
I feel like it should be possible.
We're gonna make it work.
We're gonna make it work.
I'm not ready to abandon JavaScript yet. We might have to use WASM though.
Yeah.
I'm really curious if that's actually where you end up going, just because like that's one of the things where I'm like looking at it out of the corner of my game developer eye of like, oh, like I don't know that much about it, but some of the on paper stuff sounds pretty interesting. So I'm curious if you end up like restructuring the JavaScript and you're like, oh, actually it totally works. If you're like, oh, we need to like pull some stuff in over here.
I mean, we could potentially even step down to at least something that gives us like byte contiguous floating points. Something like Go, C#, Java, they all give you that, right? They all like you can have a tightly packed array of complex structures where there's no deserialization cost, but still like pull a 64-bit float out of that, right? You can still do that kind of thing without having to worry about all the memory management stuff, right?
Oh, you for sure don't need C, right?
Yeah.
Like this is totally doable in Go, or like anything that lets you make an array of like a struct, basically, right?
Yes.
Yes. And copy it and index into it, like you're golden. Just like using Go, then you're like WebAssembly again, right? So.
Right. Cool. All right. I think I gotta like just do the whole like vaudeville.
Yeah, we should. We'll do
it
to ourselves.
I will leave it. This is a lot of fun for me. So if you guys had a good time, I would be definitely interested in coming back at some point. Obviously, I think you guys should probably hammer your heads against the problem and come back with like, here's what we found out. I'm like, oh shit, like, yeah, we didn't need WebAssembly, or like, hey, we didn't need WebAssembly. Like, I think it'd be super fascinating to come back in, however long that is, like
absolutely
6 months, whatever, and see where you're at.
We're gonna take a detour to 3D graphics next, just because it's just like we've been banging our heads against multiplayer for a while. So like, why not take on a whole nother terrible hard problem? So we like our next few streams are going to be about graphics. So we may end up digging ourselves into a deeper hole there, and if you're interested in helping us dig out, it'll be there.
That sounds good. I mean, that is definitely more my area of expertise than networking, so I think that'd be fun.
Nice. Awesome.
All right.
Talk to
you.
Take care, Dom. Take care, Steve.
Thanks so much, y'all.
Yeah.
Cheers.
Bye.